How do you suppose we would solve this trig limit? If we go ahead and try to evaluate this, just directly substitute 0, well, we would get sine of 0 over sine of 0, which is just 0 over 0, and there's that indeterminate form. So we need to do something else. And the fact that we have those sine functions and also the limit going towards 0, that should be a big tip-off that we're going to use that fundamental identity, the limit as theta goes to 0 of sine theta over theta is 1. Now we don't exactly have that here, but we can create it. Let me show you what I mean. The trick that we should be doing, I call it the accordion because we just spread it out. We spread out this fraction. I'm going to make this sine of 5x and make this a fraction over here. I'm just going to split up this fraction. Why am I doing that? Well, for this identity to work, whatever's on the inside of sine has to also be in the denominator. So for this first part, sine of 5x, I need a 5x in the bottom. So I'm going to just put it there. But I can't just divide by 5x, that would be changing the problem. So I have to also multiply by 5x, keep the equation balanced. In a sense, I'm multiplying by 1. And I'm going to do it in a clever way. I'm going to think ahead. You see, I'll put the 5 upstairs. That way I could just cancel those 5s and they would go away. But I know I'm going to have to do a similar thing for this next part, the second fraction. So I'm going to put the x upstairs above the other sign. Now for the second fraction, I need a 3x over the sine of 3x, and I already have the x now. I'll go ahead and just put that 3 there. But I can't multiply by 3 out of thin air. I also have to divide by 3 to keep the equation balanced. So all we've really done is some fancy multiplication by 1s. You'll see you could just cancel things and get the original problem. But now we can apply this fundamental trig limit. You see, we have sine of something over that thing going towards 0. We have that thing over sine of that thing going towards 0. And the fundamental trig limit says that those bits just go to 1. We have sine of 5x over 5x going to 1. We have 3x over sine of 3x going to 1. We still have that leftover 5 and that leftover 1 over 3. These were all just being multiplied, so all we have to do is 5 times 1 times a third times 1. This limit is going to be 5/3.
Hey guys, my name is Jess, the head of education here at Wise. I hope you enjoyed this video tutorial. If you want to see the complete course, please check out the link in the description. You can also go to one of our playlists to keep learning for free. If you want us to cover a specific course or a specific topic, please leave us a comment below. We post new videos every week, so don't forget to subscribe so you don't miss out on any of the new stuff.